In this video, we will try to solve these three unique problems related to sum and difference formula application. Please give it a try yourself. You can come back and watch the video till the end so that you get an understanding of how we can apply different algebraic expressions and get to the proof. So let's start with the first one. So in the first one, the information given to us is cos of alpha minus beta plus cos of beta minus gamma plus cos of gamma minus alpha. This is equal to minus 3 by 2. Using this, we have to prove that cos alpha plus cos beta plus cos gamma is equal to 0, and also sin alpha plus sin beta plus sin gamma, this is also equal to 0. So let's apply the formula of cos of a minus b in these three parts of the equation. So cos of alpha minus beta would be cos alpha cos beta plus sin alpha sin beta. Then we would have cos beta minus gamma is equal to cos beta cos gamma plus sin beta sin gamma plus the last part would be cos gamma cos alpha plus sin alpha sin gamma. This is equal to minus 3 by 2. Now let's multiply 2 on the left side. So this would be 2 cos alpha cos beta plus 2 sin alpha sin beta plus 2 cos beta cos gamma plus 2 sin beta sin gamma plus cos gamma cos alpha plus sin alpha sin gamma, and this is equal to minus 3. So there's 2 here too. Sorry, I missed that. Okay. Now, this is a unique problem that we have to solve. So instead of writing this is equal to minus 3, let's move the 3 to the left hand side too. So this will change to plus 3 is equal to 0. Now, there is no other way to simplify this further because we are stuck at one point where we cannot process this further. So let's see this unique question here. So we have 3 given here. So how can we use this value 3? So 3 can be written as 1 plus 1 plus 1, correct? So and each one can be written as, for example, cos square alpha plus sin square beta. So cos sin square alpha, this can be written as one of the ones, and other two ones can be used as cos square beta plus sin square beta, and the third one can be used as cos square gamma plus sin square gamma, correct? So let's apply that now. So we would have, this is the first one, so cos square alpha plus sin square alpha, so this is the first one, plus cos square beta plus sin square beta, this is the second one, then cos square gamma plus sin square gamma, so this is one again. Then let's write plus whatever is remaining in the equation. So what do we have here? We have 2 cos alpha cos beta plus 2 sin alpha sin beta plus 2 cos beta cos gamma plus 2 sin beta sin gamma plus 2 cos gamma cos alpha plus 2 sin alpha sin gamma. This is equal to 0. So basically what we did was, this value 3 here, we changed it to 1 plus 1 plus 1, which is further changed to cos square alpha plus sine square alpha. We just applied the trigonometric functions here. Now what we can do is, let's do a grouping of all the variables so that we get some kind of a algebraic equation. So let me use a different color now. So now what I'm going to do is, let me group cos square alpha, cos square beta, cos square gamma with 2 cos alpha cos beta, 2 cos beta cos gamma, and 2 cos gamma cos alpha. So what does this represent? So this is nothing but a plus b plus c the whole square, which is nothing but a square plus b square plus c square plus 2ab plus 2bc plus 2ca. That is why I was saying this is a very unique problem where you get to apply a plus b plus c the whole square. So the first part we can write it as cos alpha plus cos beta plus cos gamma. Sorry about that. Let me fix it. Cos gamma the whole square. Now I'll use a different color and show you other grouping. So now I'm going to group sine square alpha, sine square beta, sine square gamma, which is a square plus b square plus c square. Then I'm going to group 2 sine alpha, 2 sine beta sine gamma, and 2 sine alpha sine gamma. So this is sine alpha sine beta. So this is nothing but 2ab plus 2bc plus 2ca. So that is nothing but, let's apply. So that will be plus sine alpha plus sine beta plus sine gamma the whole square. And this is equal to 0. Now let's go back to the question. What is the ask here? We have to prove that cos alpha plus cos beta plus cos gamma, this is equal to 0, as well as sine alpha plus sine beta plus sine gamma, this is also equal to 0. Now let's see what we have what we have here. So we have a square plus b square. Basically, if we consider this as a and this as b, this is equal to 0. Now whenever there is a square function, this can never be negative, because whenever we square two negative numbers, I mean minus into minus would be plus. So if this has to be 0, both a square and b square have to be 0, correct? Have to be 0. So now both a square and b square, we found that it is equal to b. So a square represents this part of the equation, which is cos alpha plus cos beta plus cos gamma the whole square, and b square represents sine alpha plus sine beta plus sine gamma the whole square. So these two parts of the equation are individually equal to 0. So this is how we can solve question number 1. Let's try the second one now. Now in the second question, the information given to us is sin b is equal to 3 times sine of 2a plus b. Using this, we have to prove that 2 tan a plus tan of a plus b is equal to 0. Now if you observe here, in the required proof, there is no 2a plus b. Instead of that, it is a plus b plus 2 tan a. So basically what we have to do is, we have to change this somehow to a plus b format. So let's start solving this. We will have sine of 2a plus b divided by sine b. This is equal to 1 by 3. Now 2a plus b can be changed to sine of a plus b plus a divided by, and sine b can be changed to sine of a plus b minus a, and this is equal to 1 by 3. Now let's apply the formula of sine of a plus b, where we are considering a to be a plus b and b to be a. Let's apply that formula now. We just have to be a little careful when applying. So this is sin a cos b. So this will be sine of a plus b times cos a plus cos a sin b. So this will be cos of a plus b sin a. Now denominator would be sine of A minus B. So this will be sine A cos B. So this will be sine of A plus B cos A minus cos A sin B. So this will be cos of A plus B sin A, and this is equal to 1 by 3. Now in the question, the required format is of tan. There is no sine and cos in what we require. So what we will do is, we will divide this numerator and denominator with cos A times cos of A plus B. So if we divide this, then we can achieve the tan format. So what would the numerator be? Numerator is sine of A plus B cos A plus cos of A plus B sin A, this divided by cos A cos of A plus B. Then in the denominator we would have sine of A plus B cos A minus cos of A plus B sin A, this divided by cos A cos of A plus B, and this is equal to 1 by 3. Now let's divide each term with the new denominator. So the first term in the numerator, this part would change to tan of A plus B, and the second part, this would change to plus tan A. Let me remove that so that it is, let me rewrite it, just a second, plus tan A, correct? Then this divided by, in the denominator we would have tan of A plus B minus tan of A. This is equal to 1 by 3. Now let's cross multiply 3. So this is 3 tan of A plus B plus 3 tan A is equal to tan of A plus B minus tan A. So now let's simplify this equation. We would get 2 tan of A plus B plus 4 tan A. This is equal to 0. We can reduce 2 here. So we would have tan of A plus B plus 2 times tan A. This is equal to 0. So this is how we can solve the second question. Let's try the third one. Now in the third question, tan alpha is equal to 2 tan beta plus cot beta. Using this information, we have to prove that 2 times tan of alpha minus beta is equal to cot beta. Now let's apply the formula of tan of A minus B. So this will be 2 times tan of alpha minus beta. So this is equal to 2 times tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Now let's apply tan alpha is equal to 2 tan beta plus cot beta. Let's apply that. So this would be 2 times 2 tan beta plus cot beta minus tan beta, and the denominator would be 1 minus 2 tan beta plus cot beta multiplied by tan beta. Now here 2 tan beta minus tan beta in the numerator, we can simplify this equation. So this would be tan beta plus cot beta, and in the denominator we would have 1, and sorry, this is plus here, 1 plus 2 tan beta square, tan square beta, then cot beta into tan beta would be also equal to 1 because they are inverse of each other. So this would be 2 times, now tan beta plus cot beta can be written as 1 by tan beta, and in the denominator would be 2 plus 2 tan square beta. Now let's simplify this equation. In the denominator we have 2 as common, so this will be 2 by 2, and numerator would be tan square beta plus 1 divided by tan beta, and the denominator would be 1 plus tan square beta. So now we can cancel 1 plus tan square beta in the numerator and denominator. The 2 also gets cancelled, so we would have 1 by tan beta. So this is nothing but 2 times tan of alpha minus beta. That is where we started actually. Correct? And this is equal to 2 times tan of alpha minus beta is equal to cot beta. So this is the proof of the third one. So practice more and more problems like this so that you become an expert in solving trigonometric functions. Thank you so much for watching. Please share this with your friends. It will be useful to them too. I will see you in the next video.